Hello everyone, this is Fundamental Problem 16-2. In this problem, the flywheel rotates with an angular velocity of 0.005 theta squared, where theta is in radians. Determine the angular acceleration when it has rotated 20 revolutions. So we have angular velocity is equal to 0.005 times theta squared. Okay, now we have three equations to work with here. We have equations 16.1, 16.2, and 16.4. Notice the similarity between 16.1 and 12.1, between 16.2 and 12.2, and between 64 and 12.3. So this equation and this equation have time in, just like 12.1 and 12.2. This equation does not have time in. Since what we're given here is the angular velocity as a function of the angular position, we want to use equation 16.4, although you could use 16.1 and 16.2 instead if you wanted to. It's going to be easier to use equation 16.4, so we have equation 16.4 here. I can rewrite this as the angular acceleration is equal to the angular velocity times the derivative of the angular velocity with respect to theta. I have the angular velocity as a function of theta, so let's take the derivative, and we have 2 times 0.005 times theta from taking the derivative. That is 0.01 times theta. I'm looking for the angular acceleration after the flywheel has rotated 20 revolutions. So I have this angular velocity is 0.005 times theta squared times the derivative, which is 0.01 times theta. That gives me, let's write this as 50 times 10 to the negative 6. So we have 1, 2, 3, 4, 5, and then another 6 to make it 50. And then I have a theta cubed. So that's my angular acceleration. So now all I have to do is figure out what theta is at 20 revolutions. So let's say theta 2 is equal to 20 revolutions. 1 revolution is 2 pi radians. So this is times 2 pi over 1 revolution, and that gives you 40 pi. So now the angular acceleration, let's say angular acceleration 2 at theta 2, we just take this and we plug in 40 pi. So this is 50 times 10 to the negative 6th times 40 pi cubed, and that gives us 99.2, and the units there are radians per second squared. So there is the angular acceleration at 20 revolutions, and that concludes Fundamental Problem 2.